Um, but that somehow we came up with a set of rules where if you restrict to states which have an observer and you impose a rule, which kind of gets back to what something you said at the very beginning of the conversation, which is that in order to be an observer, you have to be classical. And so we sort of promote that to a principle of nature, that in order to be an observer, you have to be classical. Uh, and then we found a way of doing calculations in a one-dimensional closed universe with an observer who is present that agree with the effective field theory calculations up to errors which are suppressed like e to the minus the entropy of the observer. And so, if you're a big observer with a, big brain
Usually
and
the
a lot of
case. Yeah.
memory and,
Yeah.
you can match effective field theory to a pretty good
Right.
approximation, but it's not an approximation that gets arbitrarily good when you take Newton's constant to zero because
No,
the
now because we don't take Newton's constant to zero, right? Now what we do is we take this negativity out of picture, and what we do is we do an energy calculation, and that energy calculation falls in, right? And now we have applied cobalt 60 to this equation. And now technically with this equation we have a particle. We have many particles. We have nickel 60. Now, with nickel 60, right, plus all of this, so from now on, we're going to give all of this equation, we're just going to call it E3, right? Now, this entire equation, we just draw for reference. And now from this system, we now have a system that we can isolate, right? Now, whether that's a problem or not to him, we want to do this in space, though. People like want to, if we want to